In various parts of the world, the rock formations can show a violent history of lava and volcanoes ripping through the landscape of even the most seismically inactive countries and landmasses. One of the most common and famous forms of this is called basalt rock, that is formed by the cooling of basalt lava, which is slow-moving lava that weeps through the Earth's crust rather than exploding from a volcano. It is famed because when it cools at a specific temperature, it can create awe-inspiring hexagonal columns. Basalt rock can be found all over the world, but usually the formations only stretch no more than 100 or 200 kilometers across. However, in northern Russia, there is a basalt formation known as the Siberian Traps that is larger than all of Western Europe, an ancient wound in the Earth's crust that stretches beyond the horizon. 250 million years ago, this formation caused the worst extinction event known to have happened in the Earth's history. The time before the crisis was known as the Permian period that started nearly 300 million years ago. The period gets its name because of the Russian region of Perm that has particularly well preserved rocks and fossils from this period of time, offering a peek into what life was like. The Permian period took place just after the giant insects and arthropods that once dominated much of the planet during the Carboniferous had gone extinct. During the Carboniferous, there were already large vertebrates measuring up to 2 meters or more, but they lived like amphibians and were tied to the water for their reproduction cycle. And the earliest reptiles that lived at this time were very small. But with the giant insects gone, tied in with other factors, the opportunity opened up for the reptiles to spread out and colonize the world, making vertebrates the dominant land animals for the first time. Although they are often referred to as reptiles, it isn't the most accurate term for these animals. The further back in time you go, the more and more animals tend to look alike, because they are more and more closely related, and have had less time to diversify. By the Permian, the ancestors of reptiles and the ancestors of mammals had long since diverged. The ancestors of mammals that lived at this time were known as synapsids, which were one of the most dominant land animals living at the time, and on the surface not easily identified as being related to mammals. For instance, Dimetrodon were synapsids, and so more closely related to humans than they are to any reptiles. By the late Permian, the ancestors of all the major reptile groups alive today, like crocodiles, turtles, and lizards, had also diverged. So hidden among these reptiles and reptilian-like animals were mammals, all the reptile groups, and many groups of reptiles that never survived to the present day. During the Permian, all the continents were connected into the giant supercontinent Pangaea that wouldn't separate until the Jurassic period. The other side of the planet was occupied by an enormous ocean known as Panthalassa, that was much larger than even the Pacific Ocean. Sharks and other fish with skeletons made of cartilage had long since evolved by the Permian period, and had diversified greatly, filling all sorts of niches, and trilobites still scaled the ocean floor at this time, like they had been for over 250 million years by this point. Unlike when the dinosaurs existed, when the Earth's surface temperature soared to much higher than the current climate, interestingly, for a lot of the Permian period, global temperatures were quite comparable to today, having a tropical equator with glaciated poles. But as time went on, temperatures increased, and the climate became more arid, and deserts became more widespread around 270 to 260 million years ago. And over this time, the synapsids, that used to be very difficult to distinguish from reptilians, became considerably more mammal-like. The dominant predators around much of the globe were called the gorgonopsids, that pioneered many mammalian features, like differently shaped teeth, and having their legs positioned more underneath them to increase the efficiency of their gait. Although they weren't the dominant animals, there were other synapsids that were even more mammal-like that also lived at this time, that were called cynodonts. Cynodonts that lived at the end of the Permian had developed a very mammal-like skeleton. They had a more robust jawbone and a larger brain case, making their skull look a lot more mammal-like. However, most of the likeness to mammals was hidden in their skeleton. The marks on their skeleton show the nerve arrangement on their snout was more similar to reptilians than mammals, which is important because modern mammals use their nerves to control their whiskers and lips, so their mouth probably looked a lot more like a reptile's. At the end of the Permian, the catastrophe struck, with millions of tons of lava seeping through the Earth's crust in what would become modern-day Siberia. Preserved ash beds from the events have been discovered in eastern China that have perfect conditions for accurate radiometric dating, allowing scientists to date the crisis to 251,900,000 years ago, with the eruptions lasting for 50 to 60,000 years. Rocks in South Africa and parts of Russia from before this time contain lots of fossilized pollen, which is what you see if the area was once heavily forested. After, the pollen has disappeared and is replaced with the peculiar fossilized filaments that would have been spread far and wide. These filaments look just like certain species of fungus that feed on dead things, so they have been interpreted as fossilized fungus most likely feeding on a sea of dead trees, opportunistic organisms profiting from a cataclysmic event. The mechanisms that force the lava to the Earth's surface is thought to be a mantle plume, which is not a fully understood process, but is what causes Hawaii's seismic activity. These Siberian lava lakes may have destroyed many local habitats due to their sheer size, but the lava in of itself isn't what caused the mass extinction of trees, plants, and animal life. The great lava beds in Siberia caused copious amounts of heat, trapping carbon dioxide and methane to mix into the atmosphere, causing global temperatures to soar to some of the highest they have ever been in the Earth's history. Evidence shows that carbon dioxide levels would have reached somewhere between 2,000 to 3,000 parts per million, whereas now it is around 400 ppm, and at the beginning of the Industrial Revolution it was 280 parts per million. These carbon dioxide levels would have caused the Earth's surface to be smothered under a layer of heat difficult to imagine. What would become modern-day Kansas would have been close to the equator during the period, and there is geological evidence there that shows air temperatures could have reached as high as 73 degrees Celsius, although this is controversial. There is ample evidence that these extremely high heat levels caused rivers and lakes to dry up and deserts to creep much further north from the equator. These conditions were so inhospitable to life on land that about 2/3 of vertebrates and half of all insect species would go extinct, but oceanic animals were hit even harder, with as many as 90% of all marine species going extinct. Marine animals are generally more vulnerable to carbon dioxide increases than land animals for a few reasons. Carbon dioxide is more easily absorbed into water than oxygen, but also sea creatures are naturally more vulnerable to increased carbon dioxide levels than land animals because they don't breathe air. The carbon dioxide would have also increased the acidification of the ocean, which would have caused chaos for mollusks and arthropods as it would have eroded the calcium in their shells or exoskeleton, which may have been the reason why the Permian period was when the trilobites would finally meet their end, after existing for nearly 270 million years. The disaster marked the end of the Permian and the beginning of the Triassic period, and although the aftermath could be felt in some form or another for potentially millions of years after, populations started to recover out of the ashes around 100,000 years after the event started. There is even one animal that has fossil evidence from just before the mass extinction and after, into the very early Triassic, that was called Listosaurus. During the earliest parts of the Triassic, an almost sterile planet Earth was ready to be colonized by something, and this unlikely pig-sized creature did just that. Having little to no predators or competition from other herbivores, their populations exploded as the devastation started to decline. No land vertebrate before or after this would ever so thoroughly dominate, with their fossils being found in nearly every corner of Pangaea. So how did Listosaurus survive when so many other species perished? The body and skull shape of Listosaurus suggests they were very opportunistic and generalized, so are most likely able to eat almost any leaf or plant they came across, whereas very specialized animals are usually the first to go when an ecosystem is unhealthy. However, the most popular theory, and possibly the biggest reason for their survival, is that they were burrowers. Their fossils have been discovered inside burrows, and their forelimbs were well shaped for digging. If they burrowed deep underground, it would have given them and their young protection from the UV and the astonishing levels of heat during the day that may have been possible. However, arguably more importantly, burrowing animals almost always have natural resistance to carbon dioxide due to evolving to live underground, which would have helped tremendously with the atmosphere of the time. Burrowing is also most likely the reason the cynodonts, our ancestors, were able to survive as well. Listosaurus were synapsids as well, but a more distantly related ancient kind known as the dicynodonts, that went extinct towards the end of the Triassic. And it was the Permian and Triassic cynodonts that would give rise to the mammals over the next 50 million years after the extinction, and there is plenty of evidence that many of them made and lived in burrows too. Another group of land animals that survived were a group of reptiles named the archosaurs, that were the ancestors of birds and crocodiles, but more immediately to the time, the dinosaurs. Unlike the synapsids, the archosaurs were actually quite rare before the Permian extinction, and are known from comparatively fewer fossils. But they became considerably more successful afterwards, and the non-mammalian synapsids' numbers decreased throughout the Triassic. The reason the archosaurs became so successful after the Permian extinction is not fully understood, but it probably had a lot to do with the conditions the Earth was left with after the extinction. Although the worst of the extinction was over, the aftermath could be felt for some time into the Triassic, like a very arid climate and fairly low oxygen levels. There is evidence that archosaurs could get by with less water and had more advanced respiratory systems than these early proto-mammals. So although this massive extinction event tore through habitats and ecosystems, it was also responsible for the beginning of a new era, an era containing dinosaurs. Thank you for watching. A big thank you goes to all my patrons, especially the big contributors that are listed here. If you like content like this, then consider becoming a patron as well.